All right. Hello, everyone. Thanks so much for joining. We're going to give it another half minute while I start sharing my screen for people to filter in. But in the meantime, since we're going to talk about Apache Airflow, I would be really interested if you want to put in the chat whether you already have Airflow experience and how much, because that also helps me to adjust the talk a little bit. If everyone has a lot of Airflow experience, I will focus on different aspects in the talk. But yeah, welcome. It's really great to have you all here. Keep an eye on the chat on the other screen. And if you have any questions throughout about the content or generally about Airflow, feel free to put them in the chat. If I see them and if it's something that relates to what I'm talking about, I'll try to answer them on the go. And otherwise, we will have time for Q&A on the end. Okay, we see someone with experience, but it has been a couple of years. That is great. I have a great refresher for you for Airflow 2 and someone starting out. Awesome. Yeah, there will be elements in this talk for people who are very experienced, especially in the codes that I'm going to share in the reference architectures that you can use in your own projects. But I will also explain to you how you get started with Airflow from scratch. So there are no prerequisites for this talk. So even if you've never used it before, after this talk, my goal is that you can spin up your first local Airflow environment and write your first pipeline. Okay, with that, I think let's get started. My name is Tamara. I'm a developer advocate at Astronomer, and I'm super excited to talk to you about Apache Airflow today, which is the place where data engineers and ML engineers can meet to build awesome generative AI workflows. So first of all, something that will be useful for both beginners and advanced people using Airflow, I want to introduce Ask Astro. Ask Astro is a generative AI application itself. It's a retrieval augmented generation pipeline, so a very common pattern that you probably have seen. And Ask Astro is designed to answer questions about Airflow and Astronomer with the newest information. So you know the problem, if you're using one of the famous LLMs currently, the information is often outdated. But if you have Airflow questions, you can ask Astro and you get the newest Airflow information. But that's just half of the reason why it was built. It's also an application that was built on top of Apache Airflow. So all of the pipelines that power it and power that the data is up to date are Apache Airflow pipelines. And the whole architecture is open source, so you can just clone the repository and then build your own chat application using it as a reference. So let's actually test it. I put a lot of links in the chat on top. You should see a lot of links, and one of them is Ask Astro. So you can also test this for yourself if you want to. But let's ask it a question. And let's ask it about the newest Airflow 2.9 features, because this is something that GPT-4, which is the model that is used under the hood, will not know about because it's been a very recent release. So you can ask your question. It's fully free, so everyone can use it. And in the interest of time, I'm not going to wait for the response, but I asked the question ahead of time. And you can see this is the kind of response that you're getting. And if you're familiar with Airflow, you will recognize some of these words. If you're not, don't worry. It's a pretty good response. Like, these are features that just came out in Airflow 2.9. So let's tell it that it was correct. Okay, good bot. And the other thing that you see here is the actual sources. So in a retrieval augmented generation pipeline, we use our own data to improve, to augment the response of a large language model. And Ask Astro makes transparent which data it used. And you can see it drew a lot from this blog post about Airflow 2.9 that is hosted on Astronomer. The other thing that you can see down here is the link to the source code. This is also a link I put in the chat. And this will be interesting for people who are more advanced with Airflow. You can fork this repository. It's all open source, and it contains all of the Airflow pipelines and all of the other code that was used to create this application. So this is a full reference architecture for you. And we're very happy if you use that for your own for your own applications. I will walk through the architecture behind it in a second in the slides. But first of all, what is the plan for today, for these 45 minutes? I will introduce Airflow and Astronomer to you. So just so you know what we are talking about, if you're new, if you've never heard of those tools, or if you haven't heard about Astronomer, then I will walk through the architecture behind Ask Astro. So what are you actually getting if you're forking this repository? What is in there, and how does Airflow help deliver this GenAI application? Then I will talk more generally about use cases for Airflow with GenAI, especially the challenges that you run into when you move generative AI applications to production and how Airflow addresses them. After all that, I hope that everyone wants to get started with Airflow right now, and I will explain what the easiest way is for you to get started today. Because it's actually quite simple now. There are some tools that help you to just run an Airflow environment locally, and there aren't that many things that you need to know to write your own first pipelines. After all that, I will show you another Blueprint repository. This time, it's something that is an architecture that both fine-tunes GPT and also has an RAG pipeline. And the difference between this architecture and Ask Astro is that this architecture that I'm going to show in the demo is something that you can just run locally without having to set up any tools. The only thing you need is to have your own OpenAI API key, and I'm going to show you where you need to put that. So this is a toy that is for you to play around and to have your own application where you can actually see the changes that you're making. Lastly, I will share some more resources on how to learn Airflow, and then we will have some time for Q&A at the end. All right, with all that said, what is Airflow? It is the open source standard for workflow management. So a lot of people are already familiar with Airflow because they used it in data engineering, and there it is the de facto open source standard for programmatic data engineering pipelines. And it is a huge community. So it's being downloaded 23 million times a month, which is just wild whenever I think about that. There is a very active Slack community. I put the link to the Slack in the chat as well. Because if you ever have a question that Ask Astro cannot answer for you about Airflow, the Slack is the best place to ask. And it's also a great way if you want to start contributing to an open source project, even if you have never done it before. The committers are very welcoming for new contributors. And you can ask in the Airflow Slack for advice on your first PR. This has led to a huge contributor base. So over 2,800 people have contributed to Airflow by now. And there are also a ton of different building blocks. And what I mean by building blocks is that with Airflow, you can connect to all sorts of tools in your data ecosystem. And the building blocks are modules and Python codes that make this easier for you. So for a lot of the tools here on the screen, there are pre-built classes and ways that you can interact with these tools. And the reason that Airflow can sit in the center here of this data engineering stack and also the LLM engineering stack that is emerging is because in Airflow, everything is defined as Python code. So everything that you can imagine to code in Python can be turned into an Airflow task, which means that with Airflow, you can orchestrate any tool that has an API. So if you ever need to switch out your databases, or the newest model is that is better at your use case is hosted from a completely different service and you need to switch that out, you can just change that individual task and you never have to worry about integration compatibility because Airflow can talk to everything. And the role that Airflow here has is the one of an orchestrator. So Airflow makes sure that all of the actions are happening in the exact right moment, in the right tool with the right dependencies. The prime example here is, let's say you fine-tune a language model. Your data needs to be ready before you fine-tune the model. So this is a very simple dependency, but if you have production application, you can have quite complex structures that Airflow can accommodate for you. And once you have your pipelines defined, you can have them run either data-driven or on a time-based schedule, and you don't have to worry about your data being up to date and all of your MLOps action to happen in the right moment in time. That is Airflow. Airflow is fully open source. Now, who is Astronomer? Why am I talking to you about Airflow? Astronomer is the driving force behind Apache Airflow. So currently, we are driving all of the Airflow releases. 18 of the 25 top committers are Astronomer employees, which translates to about half, a little over half of the Airflow code having been contributed by Astronomer employees. And there's also a large ecosystem of resources and teaching people about Apache Airflow. So Astronomer is also the main place where people learn how to use Airflow. Now, of course, Astronomer is a company, so we have a commercial offering. Astro is the commercial offering, which is a platform that helps you run Airflow at scale. So you can run many Airflow deployments. You do not need to know anything about infrastructure. You can just spin up a deployment and infrastructure is handled for you. And there are a ton of additional features that just make it easier to run Airflow for several teams. If this is something that interests you, if you want to run Airflow for a larger team, or if you just want to play with it, we have a free trial for you today. So if you either scan this QR code or use the first link, I think it was, that I put in the chat, then you get a 14-day free trial with $300 in credit. And you also get a complimentary Airflow Fundamentals certification exam. So in the academy that I mentioned at academy.astronomer.io, there's a learning path that takes you from the very beginning and teaches you everything you need to know about the basics of Airflow. And at the end of it is a fundamentals certification exam, which normally costs $150. But if you sign up for a trial via this link, you can get an attempt at this exam for free. Especially for us, you said in the chat, you're just starting out. I highly recommend that way of starting out. That's how I got started with Airflow, by doing this course and then doing this exam. I will also show the QR code again at the end of the talk. Okay, that was everything I'm going to say about Astronomer. All of the rest that I'm going to show in this presentation is fully open source and possible to do with open source Airflow, no matter how you host it and how you run it. So let's talk about Ask Astro. So earlier, I put in my question. I said, what are some great features in Airflow 2.9? So earlier, I was the user here. And what happened under the hood was I was using the web app. There's also a Slack bot. First, my prompt got reworded a couple of times to get more related documents. Then there was a call made to Viviate, which is the vector database that is used in this architecture, to retrieve relevant pieces of information. So in RAG, retrieval augmented generation, this is the retrieval step. So we get relevant pieces about Airflow 2.9. Then we send that newly augmented prompt, that's the A in RAG, to OpenAI, now to GPT-4, and then we get the final answer that was displayed back to us. And that is how the answer is improved over if I would just be talking to GPT-4 directly via the API or via ChatGPT. This is one of the core ways of how you can add value to a generative AI application right now, because it's really your data that adds the value, because every one of us can make a call to the OpenAI API, but if you have an orchestration like this, you can add your own proprietary data and your application has additional value. So that's happening on the application side, but where does Airflow come in? Airflow comes in where we need data to be up to date. So we have a lot of information about Airflow in all sorts of different places in different formats. We have GitHub issues, Slack messages, we have different documentation sources. We need to take all of this information on a schedule and process it. In this case, we used LangChain to process it. Embed these processed chunks of information, so turn that into vector representations, and write that into the VV8 database that is then being used to retrieve relevant pieces of information. So that's the classic data backend to a retrieval augmented generation pipeline, and you can define all of this in Apache Airflow. The other thing that Airflow is doing here, earlier I told Ask Astro that the answer was good. So I gave it some feedback, which means that Airflow will also pick up this feedback on the back end, make sure that it's actually helpful and able to be used public, and then it writes that good answer back to VV8. So this is how the application keeps improving itself, because users keep giving feedback, and then the application knows which were good answers and can serve them to users asking similar questions in the future. This was it conceptually, but I can actually show you what this looks like. So this is the Airflow UI. If you've never used Airflow before, this is just the graphical user interface that we have, but everything is defined in code. This is just where you can see everything at a glance that is happening in your environment. So this is actually running on Astronomer, and it's the production deployment. You can also tell because I cannot pause the pipelines here because I only have viewing access. And here you can see all sorts of different ingestion sources that is being ingested into the Ask Astro application on a certain schedule. So these are all the pipelines running. All right, looking if there's a question. Just put your questions in the chat if you have them along the way. But that was the architecture behind Ask Astro. So this is one reference architecture that you can use. And I'm also very interested to hear, if you want to put in the chat, what you are thinking about in terms of generative AI, because there's a lot of possible use cases. We actually asked in December last year, we asked the Airflow community what they are using Airflow for right now, and 28% already said that they are using it to orchestrate ML AI pipelines to generally manage ML operations. So this is not just some rare use case, but this is getting more and more established to use Airflow to orchestrate these sorts of pipelines. And there's a lot of different options. The conversational chatbot that I've just shown, there are content generation pipelines, sentiment analysis, distillation, but of course, many, many more, because with Airflow, you can orchestrate any Python-based pipeline. And even if you're not defining your tasks in Python, there are ways to still run the tasks via Airflow if you pack them into Docker images. So really, you can orchestrate all sorts of different use cases with Airflow. You didn't see the shared screen with the Airflow UI. That's interesting. Let me double check. Can you see it now, Sasha? I hope it's working, because earlier I also showed Ask Astro. Okay, that is odd. Maybe, okay, Ivan can see it. I can also see it in the preview, so it might be on your end if you want to reload, or the people from GenAI can hop in. Okay. Sorry about that. I hope it's going to work going forward, but you can see the slides, I hope. All right. I hope the people from Generative AI can help you. Yeah, so there are a ton of, okay, thank you. There are a ton of different use cases for Airflow with Generative AI. So I'm actually curious if you want to share what you are thinking about, what's top of mind in terms of Generative AI use case for you and your organization right now, because we are building these reference architectures right now, and we would love to hear what people want to see, because we just want people to help people build awesome things with Airflow. So if you want to put that in the chat, also for me to read later, so we can know what to prioritize in building next. And the bottom line here is you can actually build a whole business on top of Apache Airflow. Now, if you do that, usually you have a prototype in a notebook, you have a couple of scripts, and it works great. But you will have encountered some issues when you want to bring your scripts into production. So production is usually a different beast. There are several different issues that you can run into. API outages and rate limits is a very common one. You need to have your training data always up to date, because as I mentioned, that is really what sets you apart from your competitors, the data that you can provide on top of the LLM. You have changing tools and APIs. These whole days where we look at all sorts of new tools are a testament to that. New exciting tools and new models are coming out literally every day now. So you need to know that your orchestration and your pipelines can adapt to this. You can have quite complex pipeline structures. So sometimes your dependencies get quite complex. And you need to know which data went into the training for compliance reasons in a lot of cases. Greetings to everyone else in Europe. GDPR is always top of mind for us. And of course, it needs to be scalable and it needs to be reliable. And Airflow has answers for all of these challenges. These are specific Airflow features that are listed here, and I will not have time to go through all of these in this talk. I will show two of them later in the demo. I will show data sets and dynamic task mapping. But I linked in the sets of links that I shared at the beginning of this talk, I linked a webinar that goes over these features in detail and shows how to use them in a generative AI pipeline. For the purposes of this talk, you just need to know Airflow has features addressing all of these challenges and more. So it's not just your data that sets you apart from your competitors now, it's also your orchestration. If you have the most efficient way to fine-tune your models and the best way to update your data, then you are a step ahead from your competition. Okay, I hope after all of that, you think, well, can I learn Airflow now? And this is aimed at the people who have never used Airflow before, but also people who might have been a couple of years, because Airflow has changed quite a bit and it's much easier to spin up and to handle now. So how do you run Airflow locally today? The easiest way to do that is by using the Astro CLI. This is a tool that was built by Astronomer, but it's fully open source and you do not need to be a customer to profit from it. And it's free for you to use. So what you need is you need a Docker daemon that is running, because it runs Airflow inside of Docker containers. You need to have Homebrew installed and Python free. And then if you are on a Mac, you just need free commands. If you are on Windows or Linux, there are more install instructions on the link that is on the screen here. But if you're on a Mac like me, you just run brew install Astro, and then you can install the Astro CLI package. Once you have done that, you just go to any empty directory and you run astrodev init. And this will initialize a full Astro project. So a full project that has all of the files and folders needed to run Airflow locally in Docker. And it already has an example pipeline that does something with astronauts. So you can just run astrodev start next. Takes a couple of minutes the first time because it has to pull the Docker file. And then at localhost 8080, you will see the same interface that I've shown earlier with pipelines. The difference is that it will just show one pipeline, the one example one, and you can just run this by clicking on the play button, and that's how you run your first Airflow pipeline just in a couple of minutes. If that is not possible for you, some people are not allowed to install packages on their work computers, or you just don't want to install another package on your personal computer, then you can also try out the Astro CLI in code spaces. So I will actually, let me grab this link here and put this in the chat as well. This is a repository where you can open a GitHub code space if you have a GitHub account. The one important thing is you need to use at least 4 cores. And then you can run the Astro CLI inside of this GitHub code space and play around with an example Airflow pipeline like that. There are detailed instructions on how to do this in the README of the repository. So either way, after that, you have Airflow running in some place, and now you want to know, how do I actually interact with this code? How are the Airflow pipelines defined? Because earlier I said it's all just Python all the way down. So everything in Airflow is defined as Python code, and Airflow itself is also written in Python. So if you ever need to look at the source code, it's already in a familiar language. This is the slide that teaches you how to write an Airflow pipeline with the newest version in just one slide. So on the left-hand side, you can see a screenshot of the Airflow UI. This is what you see if you see all of these pipelines and you click on one pipeline. You will see the individual tasks that are running inside of this pipeline. And in this case, we have just 2. A pipeline in Airflow is called a DAG. This stands for Directed Acyclic Graph. And this is just a structure that you can define in Airflow. So directed means you're always going to one direction. By default, it's read from left to right. And acyclic means you cannot define a cycle. So you never can go back to a previous task like that. But as long as your dependency structure fulfills these two criteria, you are able to define it as a DAG in Airflow. Each DAG contains tasks. In this case, we have two tasks. We have fetch data, which happens first, and then we ingest that data into VB8. These tasks in the code are defined by using either operators or decorators. And this example DAG actually has both of them because both of them will be useful for different use cases. So if we look on the right-hand side, you can see all of the code that was necessary to define this Airflow DAG. So at the top, we have a couple of import statements on line 1 to 5. On line 7, I'm fetching an environment variable. And then on line 10 to 15, I'm defining the DAG. So what I do here is I just use a regular Python function, ingestion DAG, and I put a decorator on top of this. If you have used Airflow a couple of years back, you might remember a syntax that is called with DAG as. This is still a valid syntax, so you can still use that. This is just a more Pythonic way that you can define Airflow DAGs now, and personally, I prefer writing it in the Pythonic way, but both are very valid ways of defining your Airflow DAGs. So this DAG here is defined with the decorator, and I just give it 3 parameters. Of course, there are much more parameters and ways to customize your Airflow DAGs, but those 3 are crucial. So on line 11, I'm saying, do not run before the 1st of May. That's your start date. I want you to run on line 12 on a daily schedule. I'm just using a cron shorthand here. That means every day at midnight. Of course, scheduling is the core of Airflow, so there are a ton of different advanced options how you can set the schedule, including being fully data-driven. On line 13, we see catch-up is false. This just means I tell this DAG, well, once I unpause you in the UI, you do not need to catch up on all the runs that you have missed since the 1st of May. So if I unpause this today, on the 8th of May, it doesn't actually catch up on all of these runs. This is just the best practice to set this to false unless you specifically want to have catch-up behavior. Now, everything that is instantiated in this function that is decorated with a DAG will be part of this Airflow DAG. So we have 2 tasks. The first one is defined with an operator on line 17. So this is the easiest way to define an Airflow task. If you are familiar with Python, you just take a Python function, and this can be a couple of lines, it can be 100 lines, any script that you currently have, and just put a task on top of it, and Airflow will pick it up and understand this is an Airflow task now. It's one of my favorite ways to define Airflow tasks because it's also very easy to define what this task will return. In this case, I'm returning a pandas data frame. On line 23, I'm calling that task with the import that I need, and then I have my pandas data frame as the object that I'm referring to. On line 25 to 31, I define another task using an operator. So in this case, I'm using a pre-created Python class called the VV8 document ingest operator. And you can see I just give it a couple of parameters. And under the hood, this makes all of the calls to the VV8 API to ingest the data that I'm giving it as a pandas data frame into the VV8 vector database without me needing to know anything about the API. So that's the great power of these building blocks, these operators. It makes it much easier for you to interact with other systems. And there are over 1,600 of them now. So there's a ton of operators to choose from and probably one for your use case. On line 33, I just say, well, fetch the data object needs to happen before ingesting the data. So I chain these two together. I create the dependency. And lastly, on line 36, I call the DAG function for Airflow to pick it up. And with that, you can already start creating your own Airflow pipelines. So I hope this helps, especially if you have never used Airflow before. But now let's jump into a more interesting use case. So this is the demo repository that I will talk about. You can see that it has 2 different types of pipelines. The one on top in blue is an RAG pipeline again. So we have up-to-date knowledge about Airflow. And in this case, I do not want to have a chatbot. I want to create content. I want to create LinkedIn posts about Airflow. So I take my up-to-date knowledge that I stole from our Learn documentation, and I ingest this into a vector database. I'm using a local VV8 instance in this case. On the other side of it, I want to fine tune because I want to influence the style that my LinkedIn posts will be in. So I have some training examples and some validation examples. Make sure that those are in the right format for OpenAI to fine tune. And I also make sure that the fine tuning will be in budget. I have a little task that makes some calculations about the tokens and would stop the pipeline if I ever accidentally go over the budget that I set. Then I fine-tune GPT-3.5 Turbo. And after that, I have a new challenger model and I compare it to the last model that was the best one that I have saved. So a champion versus challenger situation. This is another Airflow DAG. And the better model is picked. And at the very end of it, I'm just using Streamlit as a front end. This is where I can actually give it a prompt, augment it with the newest Airflow knowledge, use the fine-tuned best GPT model, and just for fun, also create a little picture with DALL-E. So this is the overall architecture. And let me show you what this looks like. The idea, let me copy the link again, because this is another open source repository that you can use. All right, the idea of this repository, if I hop over here, the idea of this repository is that Ask Astra, of course, uses all sorts of cloud-hosted environment. But if you use this, you can run this locally today. So what you can do is you can just fork this repository and then clone it. And the only thing that you need to do to run it, if you have the Astra CLI installed, is you need to take this, this file here, env example, and you need to create a copy of this file and name it .env, because then Airflow will understand that those are your environment variables. And this is a file that is ignored by Git because it always often contains secrets. So if you click here, you can see that I have all sorts of not secret environment variables that you can play around with and change. And the only thing that you need to do is to put in your OpenAI API key here and over here. And then the pipeline should run for you. Everything else, the connection between the local VV8 instance and Airflow, Streamlit, all of that should just run out of the box. So once you have done that, you will need to run the pipelines first. But after you have run the pipeline, this is the product you get. So this is just a Streamlit application. And I can use this to create posts for LinkedIn about Airflow. In this case, I'm saying, well, try dynamic task mapping. It's fine-tuned to do quite short posts, so it should be quite quick. And I also said add some space facts, because we are astronomer, we need space facts. And then you can also generate the picture based on this LinkedIn post. This is making a call to DALL-E, which is mostly for fun. But you can modify this as you want it to, because if you take this reference architecture, you can just give it different input data that you use in the RAG part of the pipeline and different examples for the fine-tuning. And then you can adapt this for any content generation. So if you want to have blog posts about the Eurovision Song Contest, which is on Saturday, then you could just use information about that in the RAG pipeline and have your own style of the blog posts as the example that you fine-tune on. So this is very easy to adapt for you. All right, and this is what DALL-E came up with. That's beautiful. I just love the way DALL-E generates text right now. It always makes me laugh. All right, so this is what you get as the end application. And let's look at the actual pipelines that you get, because I put a lot of things in this repository to help people on all sorts of levels with Airflow to get started. So I have the repository running, and I have it running locally. You can see this is on localhost 8080. And when you start up this repository, after you adjusted the .env file, you just run astrodev start. And then you will see exactly this, just without the run history. So this will all be blank yet, and these will all be paused. And you can see that I have different types of DAGs here. I have these DAGs that have the tag use case. These are part of the actual pipeline. And I also have some DAGs that have the tag simple DAGs. And those are DAGs that just show features in a very simple way. So they are all named by different features. And this is for you to play with and to experiment with the newest Airflow features. So this is running on Airflow 2.9, the newest version. And you get all of the great newest Airflow features here. But let's filter for the use case. And these are all of the DAGs that are part of this pipeline here. So if you remember, I had the blue pipeline, the RAG pipeline, and this is actually just one DAG that does all of this here. And this is this DAG here. So ingest knowledge base. If I click on this, then you can see the view. If I click on graph, this is the same view that I've showed earlier in the Airflow in one slide. So this is where you can see all of the previous runs. I had this running for a couple of days. And you can see all of the tasks in this DAG. And if you want to see the code, you can either look in the repository or your cloned code, or inside of Airflow, you also see the currently parsed code for the whole DAG. So earlier I showed one of the simplest possible DAGs, and this is an actually functional DAG. So you can see it's a little more complicated, but you can also see that I'm using all sorts of Python goodies on top of Airflow code. So this is a reference to how you can build a retrieval augmented generation pipeline inside of Airflow. In terms of what the tasks actually do, we interact with VV8. We make sure that we have the correct class. And then we ingest different sources. So I'm ingesting some text files and some guides that are based in Markdown. I'm splitting up the information. I'm chunking it with LangChain. And then I'm ingesting it. And this is the first feature that I wanted to mention. This is mostly aimed at people who have used Airflow before. But one of the core features, if you're running GenAI pipelines or really any pipelines with modern Airflow, is called dynamic task mapping. And what is happening here is that I not just have one task here, but I actually have 14 copies of this specific task, each ingesting, or in this case, preparing ingesting, and in this case over here, ingesting one chunk that I split here. So this is a way to completely parallelize processes and also adapt them, because this could be running tomorrow and I have a different number of chunks, and it would just have a different number of copies without me needing to change any code. But I can go back, for example, to a run that was a while ago. And I can look here. I had 8 copies of this task. And I can actually click here and I can see all of the mappings. And if anything goes wrong here, I can also just rerun one specific instance of this. So I could just rerun, if I click on clear here, this specific ingestion. So this is a way that you can really save resources. There are people who map over whole training of models, fine-tuning of models. And if anything goes wrong, they only have to rerun the one model that failed and not all of them. So this is a really preferable way of doing this generation of many tasks over having a loop in your code. Now, the second part, we had the purple part here, is the fine-tuning part. And all of the other DAGs in the use case are part of the fine-tuning. And on a high level, I'm ingesting my examples. Those are 2 DAGs, train and validation. Then I make sure that the formatting and cost is all correct. Then I fine-tune GPT-3 on it. And then I make sure that I have the current best champion available to my Streamlit app. And this is scheduled fully data-driven. So this is something that you might have run into. You often don't know how long something takes. So if you don't know how many train examples you will have every day, you don't know how long this DAG will take, or you don't know how long the evaluation of the formatting will take. Or sometimes an API is down, you have a retry configured, because that's the best practice, and it will wait a bit, and after an hour it will retry, something like that. So this means you cannot really have all of these DAGs on a set time schedule, because sometimes something takes longer. So these DAGs are actually connected with the other important Airflow feature that I want to tell you about, which is Airflow datasets. This was added in Airflow 2.4 and got a huge update in Airflow 2.9. So it's really a recent feature. And this allows you to schedule one DAG. So this DAG here, fine-tuning, is running as soon as both of these datasets are updated. So as soon as all of our fine-tune examples are ready and validated. And this update is happening in the previous DAG, where I'm evaluating the fine-tuning and costs. You can also see these dependencies between DAGs and datasets in the datasets view. So then you have this whole dependency structure on top of your Airflow DAGs that has the task dependency structure inside of Airflow. So you also have the DAG and dataset dependency structure. And one thing that 2.9 added, this is for the people who have used Airflow before, it's one of the most exciting features that was recently added. You can now update these data sets. So you can say this data is updated using the Airflow REST API. So you can kick off a whole Airflow pipeline structure like this by an API call. For example, from JavaScript, from a Python script, from any application. So Airflow can be fully data-driven now without you needing to think about time-based schedules. Now, in all of that, in the interest of time, I just want to zoom in on the fine-tuning DAG, because this one, we look at the DAG, can see we choose the right validation and training file, we upload this to OpenAI, and then I fine-tune GPT 3.5. And this operator is actually a custom operator that is not part of the modules yet. But you can use this if you go to the repository and to include custom operators, GPT fine-tune. This is all of the code of this custom operator. So you're very welcome to use this. And this makes it super simple. If we look at the code, we scroll down to the operator. This is all that I need to fine-tune GPT 3.5 here. So I just give it these parameters, and then it does all of the fine-tuning for me. And as a little extra, if I look at the details of this task, I have a button here, and this takes me directly to the specific fine-tuning job. So this is a way that Airflow can really make it easier for you to zoom in and check out what is exactly going on in your data pipelines. All right, with that, since we're almost at time, let me go back to the slides. Couple of resources. I will put these in the chat with some links. Hope this formats in a way that I have one too many for. Okay, so those are all sorts of links. And if you have any questions, now is the time to ask them. Thank you so much for your attention. Are there any questions? Okay, Don, does the dataset scheduling work on data in databases, not files? Or would that require a custom sensor in the DAG? That is a great question. And the answer is kind of twofold. There's a very common misconception if you have a data set. Let me check over here and pull up one. If you have a data set, this doesn't actually need to exist. So I'm using a URI here to name the data set because it's a best practice, but Airflow doesn't know about this data set yet. So you could also just name this with any string. And up here, I think, I did this here. I named a data set, just data set 1. So this is mainly a way for you to tell Airflow that there is a data set that exists, and you can tell Airflow which task is updating this data set by using a parameter that's called outlets in the task definition. And then you just set it to the data set. So this is how you can update the data set from within a DAG. I can actually show you that here. So here I have a very simple structure. So I have one DAG a data set, and a downstream DAG. And in this DAG on top, in the code, the way this works is I have a task and I say to this task, you are updating this data set. But I could name any string here. So you could also name any string of a database. And you need to make sure that the code actually updates this data set or not. You can also create dependencies that are separate from actual data sets. And then on the downstream side, we go back here. We have the data set here. And on the downstream side, in the consuming side, you can set the DAG to this data set. So yes, you could do that with databases, but if you're waiting for an actual change in the data, and this is most likely what you're referring to with sensor, then yes, you need to use a sensor because Airflow cannot actually connect to this data set yet in this way. But a common pattern now with Airflow 2.9 is that you make the call to the API that this dataset has been updated from outside of Airflow. So if the update is not happening in an Airflow task, you can still create these data-driven schedules using datasets. I hope this answered the question. Are there any other questions? Actually, for you, because you asked about datasets, you can find, we have a whole guide on Airflow datasets that tells you everything you need to know. All right, so we are at time. Let me stop sharing my screen. Yeah, thank you so much for listening. It was lovely. Check out the free trial, sign up through this link, and yeah, I'm curious to see what you built on top of these reference architectures. Ping me on LinkedIn if you have something. All right, and with that, I hope you have a great rest of the day and a great day tomorrow as well. Bye.